Good afternoon to all of you. First of all, I want to introduce myself. Myself Ankit Acharya, working as an assistant professor in Hasmukh Goswami College of Engineering. And today my content is GTU question paper solution of the subject of vector calculus and linear algebra of June 2014. So up to question number 6 we already seen this question paper. So let's see with question number 6C. Question number 6C. If T from R3 to R3 is a linear transformation given by T of x, y, z, that is equal to x plus y minus z, x minus 2y plus z, and the last coordinate is minus 2x minus 2y plus 2z. Find the basis of kernel of T and range of T. This question was asked in 5 marks. So first of all, what is the meaning of kernel of T? In any linear transformation, if you want to find kernel of T of that transformation, what we have to do? So the definition of kernel of T, first of all, that you have to understand that the definition of kernel of T says that whatever is our function, right, from domain to codomain, if you want to find kernel of that linear transformation, then we have to find such elements, such vectors from the domain such that image of that vectors that is equal to the 0 element, 0 vector of the codomain, right? So same situation happen here. Here we have a function T from R3 to R3 which is defined as T of x, y, z, that is equal to x plus y minus z, x plus x minus 2y plus z, minus 2x minus 2y plus 2z, right? So as far as our definition, what we have to do, we have to find such x, y, z such that the T of that x, y, z, the image of that x, y, z under the transformation T is equal to 0 vector, so that is 0 0 0. So that means what? To find kernel of T, we have to take x plus y minus z is equal to 0, right? X minus 2y plus z is equal to 0 and minus 2x minus 2y plus 2z, that is equal to 0. So to find x, y and z, we have to use augmented matrix, right? This is our augmented matrix because now we want to find the value of x, y, z using this augmented matrix. So 1, the first row is coming from the first equation, right? 1 1 1, okay. So this is x plus y minus z is equal to 0, so that's why the first row is coming from the first equation, that is 1 1 minus 1 0. The second row is coming from the second equation, that is 1 minus 2 1 0, right? And the third equation is coming from the third row is coming from the third equation, that is the coefficient of x, y, z, that is minus 2 2 and 0, right? So now we have to convert this this matrix into a row echelon form matrix. Now what is the meaning of row echelon form? We have to convert this matrix into row echelon form and then we can solve this solution of this equation, okay. So we have to convert this matrix into a row echelon form. Now what is the meaning of row echelon form? First of all, that you have to understand, a matrix is in row echelon form if it satisfied these conditions, these 3 conditions. First condition is if there is any 0 row, it should be the bottom of the matrix, right? So if there is any 0 row, it should be the bottom of the matrix. Now second condition, there is a leading entry, right? Leading entry means the first non-zero element in that particular row. Below that leading entry, all the element should be 0, right? So if the first row, if we have a non-zero element, the first non-zero element, then below that leading entry, below that non-zero element, we have to make all the element should be 0. Now, and whenever we are going from above to below, our leading entry is going from left to right, right? Whenever we are going from above to below, our leading entry is going from left to right. So if these three conditions are satisfied for any matrix, then we can say that the given matrix is in row echelon form matrix. And to become a reduced row echelon form, we have to add two more conditions. That is, the first condition is leading entry must be 1, and the second is if there is any column in which that column have a leading entry, then except that leading entry all the elements should be 0 in the particular column, right? So we have to convert this matrix into a row echelon form. So that's why we are multiplying first row with 1 minus 1 and add into the second row, and then multiplying first row with 2 and add into the third row. So you can see R12 minus 1. So that meaning of that term is we are multiplying first row with minus 1 and add into the second row, and multiplying second row with 2 and add into the third row. So that's why our new matrix is in 1 1 minus 1 0 0 minus 3 2 0, right? You can see from this matrix, you can understand from this matrix 1 minus 1 0, minus 2 minus 1 3 minus 3, and 1 minus minus 1, so that is 2 0, right? So that's why this is 0 minus 3 2 0. Then when we multiplying first row with 2 and add into the third row, so the third row become minus 2 plus 2 0, then minus 2 plus 2 0, and then 2 minus 2 0. So the last row becomes 0 row. Okay, so now this matrix is in row echelon form. This is our leading entry, first non-zero element of the first row, right? Below that leading entry we have already 0. The second row, this is our leading entry. Below that leading entry, the element is 0. So the following matrix is in row echelon form, and now we can solve easily. Now you can see we have only two non-zero rows, right? So the rank of the given matrix is 2 if we want to find, right? But here we don't need to find. And now the third column does not have any leading entry. First and second column have leading entry, but the third column does not have any leading entry. So that's why we are taking z is equal to k, right? So y is equal to, so minus 3y plus 2z is equal to 0. So y is equal to 2k by 3, right? Y is equal to 2k by 3, and x is equal to k by 3. Okay, so if you want to find the kernel of T and the basis for null space, that is exactly the kernel of T, the basis for the kernel space, that is k by 3, 2k by 3. This is value of x, y and z, k by 3, 2k by 3 and k. So that's why this is the kernel of T. Set theoretically we can write down with this manner: k 1 by 3, 2 by 3, 1, where k belongs to R, right? Now we want to find range of T. The next question is, you can see in the question, find the basis for kernel of T and range of T. And there is one important theorem says that if you want to find range of any linear transformation which is Euclidean linear transformation, this transformation is a Euclidean linear transformation, right? So from in Euclidean linear transformation we have a standard matrix, right? We can easily find the standard matrix. Okay, and for the range of T, that is exactly the basis for the range of T, that is exactly the basis for the column space of A, where A is a standard matrix, right? Okay, basis for the column space of A, where A is a standard matrix for the given linear transformation. In other words, you can also find the basis for the row space of the A transpose, because these two things are similar. Either you find column space of a any matrix, and either you find row space of the transpose of that matrix. So here we are finding the row space of the transpose of that matrix because it's quite easy. So definitely we can write down the standard matrix from this the given linear transformation, and then we are converting again by row echelon form matrix, and then we can find the row space of that transpose of that given matrix. So let's see. to find range of T, A transpose is equal to, see, this is our matrix A, right? 1 1 minus 1 1 minus 2 1 minus 2 minus 2 2. When we transpose of the given matrix, this 1 1 minus 2, right? This first row 1 1 minus 1 is become first column, right? Similarly, you can see here 1 minus 2 1, second row, that will become second column, and minus 2 2 that will become third column. Okay, see, right? So to find range of T, what we are doing here, this is our A transpose, right? And now we are converting this matrix into a row echelon form matrix. So 1 1 minus 2, we are multiplying first row with minus 1 and add into the second row, and multiplying first row with 1 and add into the third row. 1 1 minus 2, the first row is as it is, the second row become 1 minus 1 0, minus 2 minus 1 minus 3, and minus 2 plus 2 0. So 0, 1 plus 1 2, 2 plus 2 minus right, 2 minus 2 0. Now still this matrix is not in row echelon form, because this is our leading entry, below that leading entry we have here 0, but in second row this is our leading entry, and below that leading entry here here we have to make 0, right, instead of 2. So that's why we are multiplying second row with 2 by 3 and add into the third row, right? So 1 1 minus 2, the second row is 0 minus 3 0, and the third row is now 0 0 0. Okay, so the first and second row, now this matrix is in row echelon form matrix, clear? And now we can easily find out the basis for the row space of this transpose of the matrix. So range of T, what is the range of T? That is exactly the non-zero row of the given matrix. 1 1 minus 2 0 minus 3 0 are the basis for the row space of the transpose of the given matrix, and that is exactly our range of the transformation, right? That is exactly our range of transformation. So A 1 1 minus 2 plus B into 0 minus 3 0. If you want to write down set theoretically, range of T is equal to A into 1 1 minus 2 plus B into 0 minus 3 0, where AB belongs to R, and the basis of range of T is 1 1 minus 2 and 0 minus 3 0, right? So this question was complete. Now this question was asking 5 marks in this question paper, question 6C, right? Next question, question 7A, first part, find the derivative of f of xy, that is equal to x e raised to y plus cos of xy at the point of 2 0 in the direction of A is equal to 3i minus 4j. So this is our function f of xy, x e raised to y plus cos of xy. First of all, we have to find del f by del x and del f by del y, the partial derivative of f with respect to x and y. So first we find del f by del x. In that case, you know that y is a constant, right? Because we are differentiating of the function f with respect to x. So x is only a variable, taking y as a constant, right? So that's why the derivative of, if you want to find out the derivative of this first term, you can understand that x is only variable, so e raised to y is a constant. So derivative of x e raised to y with respect to x, that is e raised to y, right? Because derivative of x is 1. Then the derivative of cos, that is minus sine xy, and the derivative of xy, y is a constant, so derivative of x with respect to x, that is 1. So that's why del f by del x we get e raised to y minus y sine xy. Now we want to find out the value of this del f by del x at the point 2 0. So del f by del x at 2 0, instead of x we have to put value 2, and instead of y we have to put 0. In this answer, right? So put x is equal to 2 and y is equal to 0 in this equation. So e raised to 0 minus 0 into sine 0, so sine 0 is also 0, e raised to 0 is 1. So finally you will get 1. So the value of del f by del x at point 20, that is 1. Now del f by del y, similarly we find del f by del y, that is x e raised to y, right, the derivative of f with respect to y. So now x is a constant, okay, so x e raised to y, the derivative of e raised to y is e raised to y minus the derivative of cos is sin xy and then minus x. So del f by del y at point 20, that is equal to 2 e raised to 0 minus 2 into 0, that is equal to 2. So the direction of f at point 20, that is equal to I into del f by del x plus j into del f by del y, that is equal to I into 1 plus j into 2, right? So now we want to find, now our direction is 3i minus 4j, right? So the norm of this, that is 3i minus 4j divided by 9 plus 16. So 3i minus 4j upon 5, right, under root 9 plus under root 3 square plus 4 square, that is under root 9 plus 16, so 5. Now directional derivative, see, this is our directional derivative of point 20, that is I into 1 plus j into 2, so that is I plus 2j into this term 3i minus 4j into 5 by 5. So finally we get I into I is minus 1, right, multiplication, when we multiply this two bracket we get 3i square, so that is minus 3, right, and then